Hopefully you've picked up I've corrected my mistake. The average velocity from t is 0 to t is 2 is where we finish, which is t is 2. Displacement was 4. Where did we start? The displacement was 0. 4 minus 0 is 4. 4 on 2 is 2. From 2 to 4, we finished up at 4. We finished up at 0 displacement. Started out at 4, but remember our little shortcut is where we finish minus where we start. Where we finish minus the start over the time. And so that's a negative 2. So velocity positive 2, velocity negative 2. It's really important to have the direction. We're coming back towards the fixed position, the 0 or the origin. And then from t is 0 to t is 4, we're finishing at 4 and after 4 seconds, our displacement is 0. Where did we start? At 0, and of course the average velocity is 0. To graph that, we had that it was going to be a nice parabola upside down. Don't take this to think that resembles the path of the particle. The particle may have started here at 0, gone 4 units in the positive direction, and come back 4 units. So it could have been, a simple journey from this position out and back. It doesn't mean it's gone up in the air like a ball, throwing a ball. But the graph of the displacement is a parabola. You'll get used to that. It asks to put on the chords corresponding to the average velocities. So this average velocity is the chord from connecting the displacement at times 0 to time as 2, which the displacement was up there at 4. And you can see it's a nice positively sloping chord, and we've got a positive velocity. Whereas the average velocity from time 2 to time 4, and that's a 2 and that's a 4, is this chord, and you can see it had a negative gradient, has a negative calculation. Whereas if we're going from time is 0 to time is 4, then we're going here. That's our chord. What do we know about the gradient of that chord? It has a gradient of 0. D says find the total distance travelled during the first 4 seconds and hence determine the average speed over this time. So the distance travelled, I would go back to this idea. If it was displaced 4 units and it came back 4 units, think about the speedo. If it started at 0 and it went 4 units and it came back 4 units, then I think you can see that the distance travelled is actually 8 and the time was 4 seconds. So the average speed is, the formula we've always used, the total distance divided by the time, which is 2, I think that were metres per second.